Good morning, everyone. My name is Swapnil Sawant, and I'm a software developer working at Phoenix Bioinformatics. And today I'm excited to present the comprehensive modernization of TAIR. While I regret not being able to join you in person, I'm grateful for the opportunity to share our work with you virtually. This talk will cover the modernization efforts we have undertaken at Phoenix to overhaul the infrastructure and enhance the performance and scalability of the Arabidopsis Information Resource or TAIR or TAIR. To start, I'll provide a brief overview of myself. I've worked as a software engineer in bioinformatics for more than 6 years. Previously, I have developed and released Phylogenes, NSF-funded open source genetic analysis tool, and also have experience in fields like healthcare and video game development. For the last year, my focus was on modernizing TAIR. The goal of this talk is to share our recent efforts and how we made it future proof using latest technology. Uh, since its establishment in 1999, TAIR has been a cornerstone for plant biologists worldwide. It offers an invaluable collection of gene function data for Arabidopsis thaliana, which is a reference plant genome, widely regarded as the gold standard in plant biology research. With over 600,000 users globally, as indicated by Google Analytics, TAIR's impact is vast around the world. These users, spanning from academic institutions to industrial laboratories, depend on TAIR to access critical data that drives the research forward. The main activity of TAIR is producing functional annotations for Arabidopsis thaliana, making experimental data highly discoverable and usable by researchers. A common use of TAIR is to predict gene functions in agriculturally important species by comparing them to Arabidopsis genes. This is more accurate when the reference gene data is experimentally verified. Our scientific curators read through high impact published literature and link this experimental data to gene information, and ensuring high quality annotations are linked to these genes and available on our website. This process supports functional and comparative genomics, providing a valuable resource for the bioinformatics community. Each of the more than 30,000 genes that are present in the Arabidopsis genome has its own locus detail page that presents an overview of the information associated with that gene. The locus detail page that you see in the figure is the heart of TAIR and is one of the most frequently visited pages of the entire resource. And from this single page, users can navigate to other information about the gene, like the Go annotations, plant ontology annotations, gene RNA expression data, germplasms, polymorphisms, publication lists, and also external links that provide additional data for this particular resource. Until to announce that we released this new version of TAIR this May, and this major update marks the first significant infrastructure enhancement since 2011 for this useful resource. And despite being a small team of just 9 dedicated developers, data scientists, and curators, we managed to complete this extensive project over an 15-month period. Working with this limited budget, typical of a non-profit organization like Phoenix Bioinformatics, uh, we successfully released this product, and we have received positive feedback from the community regarding it. Um, Before going deep into the infrastructure, I would like to talk about the problem we faced with the older version of TAIR. Um, the older version of TAIR was built on legacy technology that was nearly 20 years old. Over time, it had accumulated significant technical debt, making it increasingly difficult and time consuming to implement necessary changes. We frequently dealt with broken features, and the cost to maintain this outdated infrastructure was substantial. The monolithic architecture of the old system was also a major pain point. It had become both costly and inefficient, leading to frequent system breakdowns and unreliable service. This issue significantly hindered our ability to provide fast and dependable services to our users. It was clear that continuing with this outdated infrastructure was unsustainable in the long run. So the organization took the risk to modernize this critical resource, which is very important for the scientific community. So why modernization? Before that, I'd like to explain what replatforming means. So, replatforming involves updating and modernizing the underlying technology and infrastructure of a website or application. For TAIR, this meant we maintained the familiar user experience and data delivery while significantly upgrading the backend infrastructure and the front end stack. This effort resulted in a website that feels familiar to our users, but it performs much better. Given the vast amount of data and numerous modules within TAIR, this replatforming required significant effort from our technical team. And we have identified several key areas where this new version really shines. So, first is faster performance. We have focused on quicker response times and search times, greatly enhancing the user experience. Second is scalability. As our needs grow, TAIR system will allow us to easily add new features and manage this growth effectively. And third is cost effectiveness. By reducing maintenance and resource costs, we can allocate our budget more effectively, ensuring sustainable operations. These improvements ensure that TAIR remains a vital resource for the scientific community for now and also in the future. Um, so this technology stack that we have used is at the heart of TAIR's improvement. I won't delve into technical specifics, but I want to assure you that this selected technologies will stand the test of time and be useful in the future. So one of the key shifts in our architecture was moving away from the monolithic structure to a more flexible and efficient setup. Previously, TAIR relied heavily on Oracle, both for reading and writing data. While Oracle is a robust database, TAIR data has evolved and grown into a very complex data structure. This evolution has resulted in slower aggregation processes that hindered our performance, making it challenging to retrieve information needed by our users. The load times were slow, and searching through the mesh of interconnected tables in the database was also a pain point. So we transitioned to a more advanced system for data storage and search functionalities while retaining our primary database for writing. This change is significant because it allows us to run updates on this Oracle database independently and frequently without affecting the main website which our users access. Also, the storage solution that we used is both scalable and cost effective. And the search technology that we used allows us to give much quicker search results, which are very relevant uh, to the users. So the new architecture enhances how our users interact with TAIR, making their experience smoother and more efficient. And also, we have improved our ability to add new features, scale the infrastructure, and maintain a more responsive and reliable platform for our users. In TAIR, we are also putting a strong emphasis on modular design and reusable components in our user interface. This approach allows us to maintain consistency across different sections of the platform while also speeding up the development process. By using modular components, we can easily update and maintain the UI without affecting other parts of the application. This results in a more flexible and efficient development cycle, ultimately leading to a better user experience. Additionally, we are also providing a responsive layout which ensures that TAIR works and looks great, whether you're on a desktop, tablet, or even a smartphone. We're also focusing on streamlining navigation. We want our users to find what they need quickly and easily without unnecessary clicks or confusion. Also, with the demand from our users, we are also making TAIR adhere to various accessibility guidelines such as ADA and VPAT standards. This ensures that TAIR remains accessible to all. So, in our journey to enhance TAIR, two critical elements have stood out, which was performance and scalability. Let's dive into the numbers. We have seen significant improvements in load times for the detailed pages which I went over earlier. The load times have improved by over 50% compared to the old system because of this new storage technology and the pre-processing step that we go through. Um, we also have seen, but it's not just about loading, but also searching and finding data inside there. Searching throughout the TAIR system has seen even more impressive improvements with reductions of up to 70% in some cases. So, with the adoption of technologies like AWS S3 and Solar, we have laid the foundation for a platform that can grow and adopt with our needs. This means we are not just keeping pace with our data growth, we are also staying ahead of it. We are ensuring that as our data and user base expand, TAIR remains efficient and capable of meeting these challenges. For our users, this translates into a quicker, more agile platform. They will experience reduced wait times and enhanced relevant results when they search for data. Also, reducing our reliance on this monolithic architecture and hosting the entire application on lightweight servers, which can which enable us to scale according to surge in traffic and so increase in data. This transition is expected to result in significant cost savings in the long run. Because of this significant leap in this tech infrastructure, TAIR will continue to be a cutting edge platform, not just today, but well into the future. So our new optimized data pipeline and Docker technology is used for deployment, are important towards making this platform more adaptable. So at the core of TAIR's effectiveness is how we handle data. So we are enhancing data delivery by consolidating information from multiple related tables from our source database Oracle in advance. This pre-processing step means that when users accesses a detailed page, it loads much faster, even though the information presented is the same as before. This improvement not only speeds up the user experience, but also boosts the overall performance of TAIR. Moving on to deployment, we are embracing Docker to transform how we manage TAIR. Docker enables us to quickly roll out updates and new features, ensuring our development and production environments are always in sync. The modular nature of Docker also makes it easier to add new modules to TAIR, such as external tools or even additional features, without disrupting existing functionality. But there's more. Docker also facilitates on-premise development, allowing us to deploy our application to organizations which have privacy concerns and want to integrate their own data on top of our application. So this makes TAIR easily adaptable to ever evolving requirements from our users. This modernization project was made possible uh, with the thanks to the continuous support from our active users without need for any additional funding, grant funding. So subscribers from libraries of prestigious institutions, including University of California, Princeton, and Oxford, as well as support from individual subscribers, allowed us to pool resources into this modernization effort. Also, by transitioning from large-scale servers to a more efficient infrastructure, we achieved substantial cost reductions as well. Specifically, we have reduced our operational costs for servers by 40%, which saves us thousands of dollars annually. This ensures TAIR remains a cutting-edge platform for the foreseeable future. The ongoing support from our user community and the technological advancement will further improve TAIR moving forward. So, our collaboration with the science team from the very beginning has been crucial in understanding our users' needs, maintaining data accuracy and relevancy, also adding custom features that are most needed by our users. Effective virtual team collaboration in this remote environment was essential for the success of this project, especially with our distributed team, being Phoenix being a remote first company. We relied on sprint planning, tools like Jira to manage tasks and track progress, and Slack for real time communication and coordination. Daily stand ups and weekly meetings kept everyone aligned and on track, ensuring that any issues were promptly addressed. Our QA process involved close coordination with the science team to thoroughly test and validate new features before release. These strategies and tools enabled us to work efficiently despite being remote, and they can serve as a model for other organizations undertaking similar projects. Our structured approach to remote work and regular communication were key to the project's success. Also, in our modernization journey, we embrace the power of AI by integrating ChatGPT into our workflow for technical development. This AI collaboration played a crucial role in improving various aspects of our technical development process. ChatGPT helped us with translating complex Oracle queries from the previous project, generating new UI component, as well as debugging bugs. By offloading this task to an AI, our development team could focus on producing results faster without being bogged down by complicated issues. This allowed them to concentrate on more challenging engineering problems and spend less time on routine work. This collaboration not only boosted our productivity, but also improved the accuracy and consistency of our code output. The seamless integration of ChatGPT showcases how AI can be a game changer in enhancing productivity and supporting complex bioinformatics projects with smaller teams. While we leverage ChatGPT for enhancing our development process, we also face challenges from aggressive bots, including bots from OpenAI, the creator of ChatGPT, which was scraping valuable data from TAIR and providing this data to train their AI models. So to tackle this issue, like data is very important for TAIR and we needed to protect it. So to tackle this issue, we implemented bot control using AWS web application firewall service. So this solution helped us detect and manage traffic from unwanted bots in real time, ensuring that only legitimate users access our resources. This not only improved performance and user experience by reducing unnecessary load to our servers from these bots, but also protected our data from being misused. Then, in conclusion, I'd like to acknowledge the incredible team behind the modernization of TAIR. Their dedication and expertise have been instrumental in this project's success. Lastly, I'd like to thank you all for your time and attention today. And I'm also here to answer any questions you may have. Thank you.
Any questions? You can come up to the mic. Can you? Okay, just a minute.
Hi. Oh,
Get a little.
Hello.
hello. Is that working now?
Yes, I can hear you.
Okay. Great presentations. I am coming
Thank
from the Jackson Lab, and I am in software engineering, IT research. So I wanted to listen to this talk. So one of the problems concern we have with our community is that they're skeptical of using migrating the workload to the cloud, but it looks like you did it successfully. One of the concerns are mostly the cost. I saw that your backend for the front end, the storage there is S3 bucket,
you.
and you have the indexes. So my question is, how do you control the egress? How do you make sure that you don't end up with a large bill for the egress to cloud resources, or for example, the storage? Is there any consideration there? Um, Thank you.
So I think you mean like access to this S3 buckets, so it
Yeah,
doesn't go over our budget,
yeah,
right?
because
Hmm.
in the cloud environment, oh,
Hmm.
okay. So in the cloud environment, when you load data to the cloud, it doesn't cost you anything, the ingress. But when you read from the cloud,
Yes.
every read will
Yes.
cost a lot of money, depending also of where the users are. So we've been really worrying about migrating the big. It looks like you have a very large data set because it's a big database. Um, we've been worrying about migrating the resources, the data to the cloud environment and getting hit by big bills when people start downloading or reading from our bucket. So I was wondering if you have seen that, because I can bring your use case back home and say, give it as an example of a successful
Mhm.
uh, application in the cloud.
Sure, yeah, that's a great question. So, uh, the buckets that we created, we specifically created buckets for the pages that people access instead of get like the data that we have on the Oracle database. We're not directly uploading that entire data to the cloud. So we are pre-processing that data and packaging it in this pages. We're uploading those pages to the bucket. So that way, the access is only limited to whatever the user really wants and has searched for. So the access to those bucket files is limited. And second thing is we implemented this bot control. So this also really reduced this API calls that so there were we saw a lot of issue where lots of these bots were accessing this data and putting a lot of load, but also increasing this cost of downloading the data. So using bot control, we made sure that only the legitimate users were able to download these files from our buckets, and also just adding more security layers so that the data is only accessed from our website and from the API servers that we have.
Thank you.
Hi, great talk. I was curious if you could speak to if the process for curation of genes has changed in your new system. And then the second part of it is if at all you use versioning in that process.
No, so the curation part is still using the source database that we had. So we have another system called Pub Search, where our curators and the community members they can log in. They kind of curate and annotate data, and the scientific team then approves or like validates this annotations and makes this updates to the source database. So once this source database is updated, we do a weekly run. So this latest data that we have, we then do this pre-processing step every week and just update our S3 buckets and our solar indexes based on these updates.
Cool. Thank you.
Hello. Thank you so much for the talk. You said that you deployed in Docker containers and like individual institutions or users who have like privacy concerns or want custom features or something like that could
Mhm.
could deploy it themselves with those like modifications. I was wondering if you have any like examples of how that's used or how you foresee it being used. Like any examples of like changes that institutions might want to make or things like that.
That's a good question. So we haven't really made a production ready version of this private deployment yet, but we have some organizations which want to use their so they want to use uh, like a snapshot point of some data and then integrate TAIR into their own system. So that way we're still figuring out like what their exact needs are. But this Docker deployment, what it would do is it would just take this snapshot of data from our database and then do this pipeline so that this S3 bucket right now is just JSON files. So like this from this snapshot, we create this JSON files and the indexes, and then do a private deployment for them.
Thank you. I would be interested to hear like a few years from now, like how it's like what custom things are used, but I guess it's too early. Thank you.
Yeah, it's too early for that for now.
I had a question. In my experience, even if you're changing something for the better, there's a certain amount of users who might still be uncomfortable. Was there anything that you did to kind of ease the transition the first time somebody logs in and sees a new interface?
Yeah, that's a good question. So uh, first of all, we did like a beta testing with a lot of our hardcore users and asked them like, what do you feel about the new site? Most of them were happy with because we maintained like the user interface exactly the same. We didn't try to modify that a lot. So because of that, they were comfortable with using this new website. But we did find some complaints where people were like, oh, we want the old version back for this detail page or this section of the detail page because that looked better for us. So but there were some users who were still happy with this new modified responsive layout, right? So like we did some A and B testing. Also on Twitter, we did some polls about, oh, you like this UI better or this UI better. And surprisingly, like there was 50-50 responses for these. So like we had to combine suggestions from all this different feedback and then provide a UI which most of the users are happy with. But again, like uh, this is the UI, we just released it and the UI is still evolving. Like the locus detail page itself has gone through like 4 or 5 different iterations, but because of this new setup we're able to do that very quickly and efficiently now.